Locating x and y positions. We're going to solve a problem that requires you to use some of your knowledge about trigonometry along with some of your knowledge about the coordinate plane. In this problem, we read, in machine work, often the x and y positions need to be known. For example, what are the x and y positions of 10 holes equally spaced with a bolt circle or diameter of 6.250 inches? We've drawn an illustration of this in this chart, and we see that there are equally spaced holes, 10 of them, going around the coordinate plane. We'd like to know the x and y coordinates of each one. When we're going to do this, we need to find out some information first. I know that the diameter of this circle is 6.250 inches. I also need to know the radius of this problem because I'm interested in the distance going from the center to each one of the holes. I don't want to know the diameter as much as I want to know the radius. But I do know that the radius is the diameter divided by 2. So the radius in this case is 6.250 divided by 2, which is 3.125. So I know the radius is 3.125 inches, and that's very useful to me. I also need to know how many degrees are between each of the circles. And to help me with this, I need to recall that there are 360 degrees in a circle. So if I started at circle 1 and I went all the way around the circle and came back to 1, I would have traveled 360 degrees. If I want to know how far it is from one hole to the next, I need to take those degrees, 360, and divide it into 10 equal spaces, which will tell me there are 36 degrees between hole 1 and hole 2, and 36 degrees between hole 2 and hole 3, and so on. Armed with this information, I'm ready to start the problem of finding the x and y coordinates of each one of the holes. When I look at the first example, I have the hole on the y coordinate. This is our easiest example. We're going to be able to do this one easily. We know something about the coordinates of that point already. We know the x coordinate is 0 because I have not moved off the origin to the left or the right. I also know the y coordinate because I remember that the radius is 3.125 inches. If I'm going from the center up to the hole, it has to be equal to the length of the radius. So it's 3.125. So the x coordinate is 0 and the y coordinate is 3.125. Those coordinates could be entered into the machining without any trouble at all. When I come to my next example, hole 2, you'll see that hole 2 corresponds to one 36 degrees away from the first hole. So I know that from the beginning to here, I've moved 36 degrees, and I can say that I know this little angle is 36 degrees. That angle, however, is on the outside of the triangle, and I need to know how much the angle is inside the triangle. I do know that these axes are perpendicular to each other, so if this angle is 36 degrees, this angle must be 54 degrees, since they have to total 90 degrees, a right angle. I also know that the radius of this particular circle is 3.125 inches. That means the hypotenuse of this triangle is 3.125 inches. I want to recall that the radius of this particular circle is 3.125, and that means the hypotenuse of that triangle is 3.125. Now if I want to know the x and y coordinates, I'll use what I know about right triangle trigonometry. I realize that I have a right triangle here because I'm moving over on the x-axis and vertically on the y-axis. If I'm going to find the x coordinate, I need to use the cosine rule because this side is adjacent to the angle of 54 degrees. So the cosine of 54 is equal to the adjacent side, x, divided by the hypotenuse, 3.125. When I'm solving this equation for x, I want to cross multiply, so I'll have 3.125 times the cosine of 54 is equal to x. I need to do this problem on my calculator, so I'll come over and make sure my calculator is clear, and I'll have 3.125 times the cosine of 54, so 54 cosine, and the answer is 1.8368. So the x-coordinate is 1.8368. Now if I want to find the y-coordinate, I see that the y is opposite that 54-degree angle, so I'm going to use the sine function. I'll have the sine of 54 is equal to the side opposite 54, y, divided by the hypotenuse, 3.125. Once again, I'll cross multiply to solve this problem. So I'll have 3.125 times the sine of 54 is equal to y. If I move to my calculator, I'll start by clearing it, and I'll enter 3.125 times the sine of 54. 54 sine, and I get the answer 2.5282. So my y coordinate is 2.5282. We're going to apply the same kind of logic to the next problem, and we need to figure out what our angle measurements are. If I look at the circle, I see I've gone 1 unit of 36 degrees. So I've moved from 1 to 2, 36 degrees, and when I move from 2 to 3, I'll move an additional 36 degrees. So I need to know the distance between 1 and 3 is 72 degrees. So we know the angle between 1 and 3 is 72 degrees. Now 72 degrees is outside the triangle. I don't need to know that angle, I need to know the angle inside the triangle. I remember that these two angles are complementary, they form a right angle, so my interior angle is 18 degrees. Now I also know that this is a right triangle because I've moved horizontally and vertically to get the coordinates, so I'm going to use my right triangle properties exactly as I used them in the previous problem. I know that the hypotenuse of this triangle has not changed. It is still the radius of the circle, so it is still 3.125, and I'll use that in my right triangle problems to help me solve this triangle. If I want to find the x-coordinate, it's adjacent to 18, so I'm going to use my cosine function. I'll have the cosine of 18 is equal to the adjacent side, x, over the hypotenuse, 3.125. When I cross multiply, I'll have 3.125 times the cosine of 18 is equal to x. I'll move to the calculator to do this. Clearing my calculator, I'll have 3.125 times the cosine of 18, so I'll put in 18 cosine, and hitting equals, I have 2.9721. So I know the x-coordinate is 2.9721. Now I need to find the y-coordinate, and I'm not going to do anything different than I did in the previous problem. The y-coordinate is the vertical distance from the axis. So I know that I've got the y opposite, the 18-degree angle, and I'm going to use sine. I'll say the sine of 18 is equal to y over 3.125. When I cross multiply, I'll have 3.125 times the sine of 18 is equal to y. And I'll finish this up on my calculator. I'll clear out the calculator and enter 3.125 times the sine of 18, 18 sine, and that equals 0.9657. So the y-coordinate is 0.9657. Once you have the first quadrant angles, it will be easy to find the coordinates of the remaining angles. They are merely reflected across axes. The numbers will not change, but the positive and negative values will. So once you've found the first quadrant angles, you're in good shape for the rest of the circle. And by a simple application of the right triangle trigonometry rules, we can easily find those locations. Keeping in mind the trigonometry rules will help you solve many machine-based problems.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.